Hello and welcome to a new episode in our series of videos of interesting conversations related to various design challenges and agile challenges and architecture challenges. I'm Bolboaca, coming to you from Mosaic Studios, and today my guest is somebody who's been around, who's done a lot of contributions to object-oriented programming, who's been a thinker in the software design areas, in design patterns for a long period of time. And I'm very happy to have with me Rebecca Wirfs-Brock. Hi, Rebecca. It's nice to see you again.
Yeah, good to see you virtually, Alex.
So we met first time in Porto, where we were speakers at the same conference at Agile Porto. But what I didn't know back then is that Porto was also kind of a part of the PLOP communities, pattern language of programming. There seems to be a strong center there. And I also attended one of your courses on design, which was very interesting. And I didn't know back then a lot about you, actually, which is a shame, because I like to know more about the history of programming, and I believe you are a big part of this history, actually. So can you tell us a bit, we discussed with Ellen Wirfs-Brock about Tektronix, and I know you are also involved there.
Yes. Well, so Alex, you should realize that, yeah, we were a Tektronix family. So Alan was working at Tektronix Laboratories, bringing out the first Smalltalk. And at that time, I was a principal engineer working in graphics workstation. And at that time, my manager's manager decided to take over leading the Smalltalk at the AI machines group. And I was coming back from maternity leave, and he basically said, you want to join as a principal engineer working on productizing the Smalltalk. And I said, great, Alan's been doing very interesting stuff here. I don't know anything about this Smalltalk, but it's much more interesting and interactive than the graphics terminals that I'd been working on. Anyway, so I joined, and 2 weeks later, the manager of the group left to go work elsewhere at Xerox PARC, and I started. My manager said to me, "Well, would you like to manage the group?" And I go, well, okay. So I was the manager of the first Smalltalk AI machines software effort. And after that, since I'm really an engineer, I went back and worked on color Smalltalk and trying to figure out things. And I got involved because Smalltalk was, at that time, we may not think so today, but at the time, its graphics were cool. It was doing things that were, you could programmatically do stuff that was just very interesting. So I got in there from the graphics angle of Smalltalk, with these windows, could overlap, and we could do all these interesting visual effects. And it just happened to be that there were objects as well.
Yeah, so I guess this brings us to object-oriented programming, because that was, from what I understand, Smalltalk was one important part of object-oriented programming back then. It was also inspired by Alan Kay's vision of OOP. So what was the initial vision?
Well, I think that the idea of a personal Dynabook is, even back then, what we had in Smalltalk graphics workstation was pushing the edge of what you could do technically with a personal workstation, and potential of really doing things where programmatically I could do very playful kinds of things in this very nice environment that was very forgiving of you making programming mistakes, because you could stop and start and it was alive with objects, which is something that we really don't have any other environment like that today. We should talk about living objects and what that really means, because Java certainly isn't that way. But anyway, it was an environment where I could write an application. I didn't have to think about all the things of connecting to the operating system or doing things, because the class libraries in there were very conducive to doing programming. I could do simulations, I could do graphics, I could do visualizations of things. So it was pretty neat. Now, is that Alan Kay's vision of children programming without without thinking, by just gesturing and having very natural, organic kind of interactions with your computers? No, but it was a big step forward from what I was doing before. That was PL80, which is a one step up from an assembly language programming on 8086 machines. So it was a big step forward.
So how would you design a program back then? What were the things that you were thinking about?
Well, it was interesting that when I first started programming in Smalltalk, I had to translate the way I was thinking in the procedural programming and try to map those to these weird concepts like messages, objects, and in some sense, I needed that sort of bridge of, well, what's really different between a call to a method on an object and a function call, a procedural call? Well, because there's an object that has retained state, which is very, very different than when I'm just calling a function, plug in the parameters, call stack, return. There are these things that retain state over time that interact. So when you think about what does it mean to program in the Smalltalk environment, not only would I have to think about conceptualizing my program to do things, but there was this environment where all these other objects were alive and doing things too. So everything from my debugging environment to my browsing to find code to create classes was alive and part of this object-oriented infrastructure around me. So it was kind of weird, when you first started out, because you say, well, what is my application, right? I have to start something. I have to interact with what's already there, and I have to kind of carve out conceptually what my set of objects are doing. And yeah, we had lots of help there with the classes to do that. If I wanted to construct a view, there were different kinds of views that you could, create classes from. But the behavior of your objects that were going to retain the state over time and interact with each other was the real challenge. If you might say, in today's modern terms, your domain model, your set of objects. And so then figuring that out was kind of interesting too, because when you think about it, what behaviors and what data should be partitioned into these objects that interact over time to accomplish something was something that you hadn't really structured a program that way before. I mean, it was very different. You know, I know how to do functional decomposition, but this was quite different. And so that's kind of what it was like. It was not just cut and dried how I make an application. We had to kind of figure it out. Yeah, there's this visual representation. There's this thing called model view controller, but the model part was like, whoa, you know, a set of interacting objects that exist over time, working together to do something. And okay. So that was a quite different approach, yeah. So I did not figure this out on my own. I kind of did, I'm going to say, crappy programming. Observed people who really got how objects interacted and sort of seamlessly started building these very interesting applications, and observed what they were doing and said, okay, I can learn a lot from Brian Wilkerson, the co-author, one of my co-authors on my first book, or seeing how Ward Cunningham thinks about objects and their interactions. And actually Ward was quite a, he made all objects very lively, quite different designs than I might do, but it was just an inspiration. So it wasn't like we had a pattern, if you will, for programming when we first started.
So when I first learned object-oriented programming, I was probably around university years. I came out of learning first BASIC and then Turbo Pascal and then a bit of C, C++. And then I kept trying to understand what object-oriented programming was about, and everything I could find in every book about programming, there was always a chapter on OOP, and it was always about three things: encapsulation, inheritance, and polymorphism. And I couldn't just wrap my head around these things. It was very hard to grasp the idea. And after many years, I've come to the conclusion that perhaps there's too much class in this and not enough objects. Is it something you would agree with, or?
Well, I tend to think that when you say objects, I tend to think of behaviors. And perhaps that's a similar kind of way of thinking about structuring it. And so when I think of behaviors, it's interacting behaviors. So it's objects that interact is really what it's all about. Now, the fact that I can use classes to get a consistent framework for extending is useful if I'm building kind of a library like we did with Color Smalltalk, or we did with various different kind of capabilities. We built color models using classes. But when I'm writing applications, which is different than writing libraries, it's not that I do that as often. So if I'm thinking about it, behaviors that are like interacting is really what it's about. So it really is about objects and their the way they interact with other objects. But you know, classes are not, I'm going to say, bad or evil. Sometimes people say, well, oh, can I structure it? If I look at the Smalltalk class library, for example, the most beautiful class library, and I say this, you know, with kind of like emotion, is like the collection hierarchy. It was built in a way that, because of just 3 primitive operations in the superclass, for a lot of different kinds of structures for collecting and organizing, like sets and ordered collections and lists or whatever. Common operations over them were defined in terms of 3 methods that had to be implemented by the subclasses. And then you got all this behavior for free. Now that was just beautiful design. And it was designed so that when you invoked a method, it would return the object that was there in the same state, so you could, keep chaining things along in a very nice way. So that was just brilliant. Now, have I seen other people who didn't, I don't know, have the beautiful kind of sense of creating classes do that? No. And so that's where I think, classes and inheritance gets a bad rap, is because it's been poorly done. I'm sure you've seen things in C++ where you call down to something and and friend functions and things like that. It's sort of setting you up for ugliness, I think.
Yeah, I've seen deep hierarchies where you would have, because you needed one function somewhere low in the hierarchy, you'd implement it in the base class somewhere very higher up, and so on. So there was like
right. So you're putting behavior that everyone inherits just because you want it up there. Yes. Yeah. See, these things are not. So to me, I guess, when you talked about inheritance, or what you learned about in books, was it kind of gave you a simple introduction, and it gave you examples like animals, right? Or, it was thinking about hierarchies and classification in the classic Aristotelian sense. And then people would say, well, wait a minute, what about birds that don't fly, right? Birds have fly and you don't have a fly method and whatever. So anyway, yeah, I spent years in object design teaching people how to think about using inheritance in a proper way, actually. That was part of whatever training I did with people. And I thought about, that really one of the things that was never really explained nicely about good use of inheritance was that if I define an abstract algorithm, right, an algorithm that has steps that could be replaced by, concrete objects, classes that knew what to do, that defining a set of abstract algorithms at a higher level class, that's behavior, it's not data, that could then be implemented differently but still conform to the interface, is a really powerful way of structuring things. So I like that use of inheritance, but all these other sort of, I would say, bastard abuses, or I inherited this, but it really doesn't work, so don't call this method. It's terrible. It's just bad behavior, bad programming. So it's the languages gave you capabilities, and you just didn't know how to use them. So I essentially spent a lot of time. And when I moved to Java from Smalltalk, because I had to get over Smalltalk once the world got over Smalltalk, I would use examples in Sun's libraries of bad design and have my students fix them up. Let's change the date class.
Yeah, and also things like. So you have a bunch of functions, but in one of the implementations, you don't need it, and then you throw an exception there because, of course, or you have like 7 levels of inheritance of classes.
That's a little hard to keep track of. Yeah. Well, so we say, these days, I would say, folks kind of have distilled this down to saying, well, it's favor composition over inheritance. But I would say that defining interfaces and implementations that can be extended is really the better approach. So inheritance isn't evil, it's just limited. Or think about what you're trying to do. It's actually very interesting when you start, someone's trying to define a framework with a set of classes, like, and I could say graphics objects or collections or different caching strategy kind of classes or whatever. it's very interesting to kind of test that they are working well is if you can subclass and extend what someone's framework is. And that's a great test of like, well, can I subclass it? Will it work? And that usually proves different flaws that are in there in people's class hierarchy designs. And I have to say that that kind of exercise of how might I extend this should be something, if someone's building a hierarchy, is something they should think about. Now, not everybody does that, but if I'm doing some kind of messaging structures or things, let's think about it, how can it be extended?
So how about encapsulation? Because we've seen there a lot of, so you have hidden variables and then you add a bunch of getters and setters, because that's how you need to access those. And I guess there's no
so
point.
Encapsulation is not the same as information hiding. And I want to make that very clear. People sort of go, oh, well, there really is no difference between the two. It's sort of the same fuzzy concept. But encapsulating is putting related things together, in my definition. And information hiding is purposefully choosing what you will reveal to the outside world. So just because I have information doesn't mean that I should have setters, right? I might want to be able to get information, but I might not be able to set information. And vice versa, right? If I'm allowing you to change the state of something with a setter, should I be able to retrieve that, or is that just a configuration that I'm doing? I mean, it really requires you thinking about why am I allowing someone to poke at the state of an object? Is it to set it up? If so, maybe it's better in a constructor, right? To initialize it. If I need to change it during its time frame, is it just a setter and I always have a getter for it? I mean, really, why is there this belief that there's a symmetry there? There really shouldn't be. If I'm setting a behavior, setting a variable or something that should be private, maybe that variable is being used and modified over time, and so I really don't want to just have this blind correspondence. Maybe it's really derived. Maybe a getter is really a derived function, right? It's tweaking it now or adjusting it or whatever, so it has interesting behavior behind the scenes. But when we think of it just as being I'm going to say a transparent capsule to shove data in and out, then it's not very interesting. Yeah, it kind of limits possibilities. Yeah.
Yeah, so coming from Java, I was surprised to see things they were doing in Python, where everything is public basically, but you just by convention say, don't touch these things because they might change and it will break your code. So
and so it in Smalltalk it was kind of the same way too, right? I mean, I could access things, but we kind of had style guides for not doing things. And so that's why the idea of where I'm very cleverly in a language that allows me to specify all this stuff, chances are you're going to get it wrong. So do you like Python programming, that freedom it gives you to make mistakes?
I actually like Python, and I think on one of my favorite languages, which is also inspired by Python, has been Groovy. I've worked with Groovy a lot, which has brought an interesting realization, because we've been using Groovy, and Groovy has what's called, so it doesn't have mandatory typing. You can use types if you want to, but it's not mandatory to use them. And we use types at the edge of the system and not use types inside the system, basically. So we use the input and output types. And it was very interesting because what I would expect is that we will have more problems like that. But it turned out that actually no. And I can't explain it, but one of the reasons that I can think of is, in that case, the only thing you have as information in code is the names. And so this forced us to give better names and have smaller functions inside the code. So it was unexpected, but since it's been only a one-time experiment, I cannot say whether there are other factors involved. What is your opinion on strong typing?
So that's kind of interesting when you talk about just, when I'm doing object design in, I'm going to say, strongly typed languages or typed languages like Java, which kind of force you into weird things as well, is that when I wrote my second book, the object design book, I talked about how I have to understand trust regions within a design. And that sounds like a strange concept. It's not the same as a bounded context and domain-driven design, but it's where I want to guarantee the integrity of the information that gets passed in. And so if I understand what those regions are and scrub information and deflect it when I can, right there at the borders of stuff coming in, then within the rest of the design, the collaboration space of those objects, I don't have to do all this sort of checking, right? I can just send and receive things, and usually if I have an error, it's a programming error. It's not a type error. And those are different kinds of errors it's a logic error. It's not a, oh gee, I'm returning something that's the wrong thing because I screwed up in my program. It's not a type error. And so if you understand those regions of where you need to, I'm going to say, defend, and you can keep it very clean and simpler on the inside. Same kind of approach goes actually for exception recovery kind of actions, which Smalltalk was very cool in that you could recover from exceptions and restart pretty easily, but you didn't have this sort of unwinding exception complexity of Java. Let's not go there with Java. We could talk about Java all day long, but about how it made it challenging. But the whole kind of idea of when I'm crossing a boundary of where the information is known or where the correct response to something is known, that's when I should throw an exception, right? I don't know, so here I am. But all these little things below, I shouldn't just let these lower level things. It's the same kind of principle. When you kind of follow those sort of design practices in object-oriented design with languages that kind of are yucky that way, it makes it so much easier. I don't know how many times I've seen, and again, if I'm reading in information from a database or whatever, isn't that the logical place to check that this is coherent, not somewhere up at the UI or something? So it's like, if I start thinking about this way, it makes it a lot cleaner. So I'm not surprised from your Ruby. You think it might be naming. I'm thinking it's just relaxed, this sort of like vigilant but useless checking everywhere, right? If I'm passing something along, even in functional language, if I verified it in one place, why do I have to keep checking? I mean, do I? No.
Yeah, so this is, well, I expected that we would have, for example, to write more tests or to be more careful but actually no. It turns out that we were writing quite a good amount of tests, but just enough to cover the behavior and nothing related to types or things like that, the type
or little
checking.
details. That's actually very interesting, because I was working on a TDD course with a colleague, a person you know, Joe Yoder, and another patterns folk, and my Java code and my testing for the kind of classes I wrote. He says, "Oh man, it's really hard to introduce a bug into your code because it's your tests and these things." I did not test everything. I tested from almost the outside in rather than the inside out. And so when I was having these various strategy objects doing things for rate calculation, it's like, no, I don't need to test each little one. So I mean, I ended up with less tests, but they were pretty bulletproof. I mean, it was very solid. So yeah, I'm not I don't know. That's an interesting observation that you made, because I tend to think that if I start, thinking every setter and getter needs a test, boy, I'm never gonna get to the really interesting stuff that matters.
Yeah. So you mentioned living objects, and I guess that's an interesting part. I don't exactly know how this worked in Smalltalk, but from your descriptions before, it sounds almost like you had a world of objects and you're adding some more objects into that world and kind of interacting.
Yeah, that's exactly like it's you bring up the Smalltalk system, and it was an image that had been, I don't know, pickled. Pickled is the right way. Romanians pickle things, right? Pickled. Yeah. So that when you bring up the start it, you could follow the startup and you could see all the objects, are there and alive and initialized, and there they are. So it's the case that when you were even programming or debugging or everything, you could inspect and change every object, even the running objects that were running the system, which is different than compiling and then having the objects run in an execution space with breakpoints. I mean, everything. I could change how interrupts were being processed. In fact, I was writing code at that kind of level. I could change how interval timers work. I could really break the system, but then I could change things and recover, right? So if I could work on the plumbing while it was running, which was, and observe these things, change them. It wasn't just that I always wrote tests. So, I mean, the TDD kind of practice wasn't there. We wrote lots of tests all the time. In fact, there was a workspace where you would write code snippets. And in the Smalltalk, there was a category that methods were under, and one of the categories that was there that was by convention was testing. So you would write tests. So those were there, but the whole environment was such that if I was doing, writing some code, I could, and I discovered I had a problem in my logic, I could change the code and just go on there, right there. So it wasn't just that I was doing testing. I was doing testing and debugging and changing the things and fixing it up and trying experiments and coming back and creating that way and seeing all these objects. So it was a very, very different experience than I find, debugging in a browser or, in my favorite IDE. I'm an IDE person, I have to admit. That's kind of an old school thing. These days, people are not into IDEs as much.
Yeah. So it's interesting what you say, because I'm imagining that you'd have a lot of fast feedback and quite interactivity with the existing system. So you could basically figure out if things were working together as a system rather than just your small part or your.
Well, you were pretty much focused on your small part, but by convention, you left things in workspaces, which were basically windows that had code snippets to try out interesting things. Here, try something interesting. Because again, the definition of what an application is was kind of fuzzy, right? And that you would, when you're done at the end of the day, you should have added meaningful tests to that testing for particular classes. But it's not like I wrote the tests first. I was always testing and exploring and experimenting. So it's a little bit different flavor than the, classic test-driven development, which is write the test first. No, I'd write code and see what happens, and then I'd go in, and it was much more dynamic than that. But the environment really supported that.
Yeah. So what was the difference? How did C++ and Java get so different from Smalltalk?
Well, I tend to think that Java class libraries were not designed by people who actually used them. I hate to say that, but it's like, and I'm not picking on Java per se, but when we got the Smalltalk classes that came in the basic Smalltalk that Xerox PARC had, they wrote classes that they used, right? So they were users of those classes. So sure, they weren't all perfect, but they were actually, the whole environment was something that was used. So it wasn't I was writing libraries for someone else. C++, had its heritage of I need to extend and preserve, but also add this notion of classes and inheritance to this existing non-OO way. So it was a hybrid multi-paradigm kind of language. And it first started out with a compiler. You could compile to C. I don't know if you remember those days, but I remember writing C++ code, and then it spit out stuff and transmogrified the names and whatever and did all the stuff. And I very first C++ started out with that. It has to compile to C that's then compiled. And so, it started out with different goals. And Java, I think, started out with the goal of, well, hey, we're doing some experiments about exceptions and types, but we're kind of not going to be like C++, and we're kind of not going to be like Smalltalk, but we're kind of, it started out sort of halfway in between, it's like, oh, okay. And, we're really great about our libraries, but are we really using them to write serious stuff? So, I think people at, I know folks that worked at Sun on things, and I have never really heard the story of who designed the date and time classes there, but I would really love to know that. Well, just for example.
And the input-output, it was always very difficult for me.
Oh, well, so that's actually interesting in that streams in Smalltalk were done well. But Java had different goals. It was also designed to handle directly, doing more, I'm going to say, real-time kind of capabilities too. At least it thought it could. And C++ definitely was along that path too.
Okay, so back then, as far as I can understand, there were a few things that happened kind of at the same time. There was this attempt to understand object-oriented programming better, which led to things like the design patterns and plop and these kind of things. But at the same time, you had extreme programming kind of growing in parallel. And it all seems to have in center word Cunningham and Portland, basically.
Yeah, I think there's a lot of innovation that happened at Portland. And, Ward Cunningham is one of those people who, well, he invented the wiki. Well, he invented CRC cards, that then I wrote a whole book about, that they were involved in extreme programming. And I would say at the time, probably it was more Kent Beck, who also worked at Tektronix before he left to go work at Apple and various places. So it was, a very small group of people that were interested in objects. There's also the University of Illinois connection. So you know that the Gang of Four book, or the Design Patterns book, Ralph Johnson is one of the authors of that. And he was the only small talker of that group of four. But the book, if you go look at that classic book, it had no small talk influence. I mean, it was pretty much C++ was dominating, in those days. But yeah, there was a set of people. I mean, the very first OOPS conference, Object-Oriented Programming Systems, Languages, and Applications conference, was held in Portland in 1986. I mean, think about that. That was a long time ago. Now that is before the time of XP, most definitely, extreme programming. And it was 500 people showed up. Adele Goldberg was, involved in the conference. Alan Wirfs-Brock was involved in the conference, and they rejected my color Smalltalk paper. So, I think I had a poster that year, and then the next year I, wrote a paper about color Smalltalk. Maybe it was a couple of years after that. So I was an outsider wanting to get in, but it was, it sort of took off in a very interesting time, with objects coming from both industry, people writing code for applications, as well as researchers. So it was a very cool conference. I don't see many conferences where there's such a mix, and we all listen to each other. So there were people talking about, how do I implement OO programming languages, and people writing papers that were just practitioners about, well, how do I use inheritance correctly? So it was pretty exciting times. Yeah, it was. So I think that there's a confluence of, and there are other folks that were involved in the early times too. I mean, Jim Rumbaugh and Grady Booch were involved. Steve Miller, Sally Schleyer, were thinking about, well, how to Peter code. How do I think about programming in OOP? But not only that, but what's my brand of modeling? Got in there very soon afterwards. What's my methodology? So within that first, from first OOPS law to the first 5 or 6 years of that conference's existence, there was a lot of change and a lot of interaction and a lot of special interactions between academics who were not just theoretical types, as well as people who are really trying to push, object-oriented programs in programming. That was pretty kind of cool time.
Yeah, so from what I've discussed with people involved in both design patterns and the OOP and the extreme programming community, it looks almost as if, and I may be wrong, but it looks almost as if you had one current looking to structure and to get more discipline in the sense of, diagramming with UML, design patterns with some repeatable things. And the extreme programming folks could seem to be kind of more rebellious and trying to kind of reinvent a lot of these things. I don't know what is your opinion on this.
Well, I actually think that there's always been this, what can we do by writing programs community, and that may be embodied by extreme programming, but maybe that's not fair to only cast it as that. And then there was the group who wanted to commercialize it for larger scale kind of applications. And so when you talk about diagramming and modeling things, if I'm just a single programmer, I don't need to do that. If I'm working on a team of 3 or 4 people, what am I doing? Why am I doing that? But if I'm wanting to try to convey a design to other people, how do I do that? And back in the early days, there was no convention. There were booch clouds, little puffy clouds to represent objects and classes. And I had this strange notation in our first book that we came up with. It's sort of rectangles and little notches for where collaboration contracts were. But it was very informal. It was all hand drawn. And then when people started coming out with tools and, basically came from the entity relationship modeling into the OO diagramming and drawing, that influence actually really was how, Jim Rumbaugh had been working on that stuff. That sort of came into, and it was very precise, like how do I understand the cardinality of relationships? And I could go on, but I won't. There's probably more interesting things to talk about. But so there was that need to do that kind of modeling for larger scale systems, or at least it was perceived as being a very useful activity. And I actually, I've just like I got over my last Smalltalk application I wrote was probably in the early 2000s. And moved on to Java, I kind of saw or perceived the need for some way of representing a design without, looking at all, staring at the code. Now these days, and so I became fluent in UML, and that's okay. But no one today really is. I mean, I'd say in academic papers, people write stuff. And the thing is, when there's a conceptual disconnect between my program and what I'm trying to express as a design, and I don't see any benefit from it, it's a problem. I don't know if you know this, but some of the early tools really did allow you to round trip between the code and generating a design. So it kind of felt like Smalltalk. And I remember using Peter Code's company's tool. It was actually written by some folks who lived in Russia at the time. But it allowed you to write your code, extract the design from it in class diagrams, and then tweak it to remove details so you didn't have to show all the details. So you could abstract but not lie. And then you could go either way, and it was truly a round trip tool. It's the only tool I know that was that connected to the code. Ivar Jakobsen with Objectory, their first modeling thing before he joined Rational, was written in Smalltalk. And it allowed you to do what if kind of experiments in the model too. So you could change it and it would, pretty dynamically change your understanding of the design. So it's more along the lines of the tool that, I don't know if you know Simon Brown's work, but where Structurizer is something where I can write and it can pick out the code and help me with a model. It's more like living documentation that way. And so there were some early tools like that. Just unfortunately, the companies that did that didn't stay in business.
So I think if I remember correctly, responsibility-driven design was kind of your first contribution to object-oriented programming and design, right?
Yes, yes.
Can you say a few words about it? Because I'm pretty sure many people don't know what it's about.
What it is, yeah. Well, so responsibility-driven design was an outcome of a paper I wrote with Brian Wilkerson for an OOPS law. It got accepted the same year that Ward, it's like 1989, Ward and Kent's paper about CRC cards as a tool for teaching laboratory tool for teaching object-oriented thinking. And responsibility-driven design was a very short paper that was written showing that if you thought about design of objects in terms of behaviors, what they were responsible for, and how they interacted with, even with the same problem, that you would structure things differently. So I'm thinking about what is an object responsible for and how does it collaborate with others as the primary way of thinking about it. I will create a different design. And we used, as an example, how would I even design something that does some graphical images? If I think about it in terms of, in contrast to a data-driven approach, where I take and focus on the data and encapsulating it, not hiding it, but encapsulating it, I will end up with a very different design. So that was kind of, and we argued that this design had more, was a different way of thinking about it that was more natural, and that's kind of the start of how responsibility-driven design happened. And then after we wrote that paper, the next year, over a period of 4 months, we wrote our book on object design. And it was called Designing Object-Oriented Software. So we didn't put responsibilities in there. In the title, probably should have, didn't. It was just, how do I think about designing object-oriented software? Now, one thing about where that inspiration for responsibilities came from as a way of thinking about it is, I don't know, this is a small talk trivia challenge. If a class does not implement a method, but it expects a subclass to implement it, and you want it to have an error if that subclass didn't correctly, override and re-implement the method, you would say self-subclass responsibility. You'd write a method that would say self-subclass responsibility in it, and if the subclass didn't have it, you would get an exception. So to me, when I was first learning Smalltalk, and again, Brian knew more about Smalltalk than I did, and Ward and folks, to me, it was all about distribution of responsibilities, which was so that's kind of how it came to being. And then observing later on with responsibility-driven design, we used fairly lightweight techniques to model and understand a design before you would approach programming it. CRC cards are something that I promoted. And in the next book that I write a book about once every millennium, but it was introduced the idea of role stereotypes, or different characterizations of behaviors that interact with each other. So yeah, to me, responsibility-driven design is something I think that was known at the time, and it inspired a lot of people who were, X-driven, right? So behavior-driven development, test-driven development, domain-driven design, they were all inspired by responsibility-driven design. And those folks will tell you that. So I don't know why I chose the word driven. That just happened, but it was responsible, focus on behaviors, not just the data, but interacting behaviors. And so that's kind of the approach. So that's a little bit of the story of that.
Yeah, and it was interesting because basically the good practice of TDD is to focus on behaviors. When you write tests, you should focus on behaviors. So it sounds like there's a lot of background to responsibilities. Are responsibilities and behaviors kind of the same thing?
It is. Well, so here's the thing. Objects have behavior, applications have behavior, but when you're trying to think about where you want to divide up the work and the information, you have to think about what this design element's responsibility is in the overall sense. You know, we as citizens of the world have responsibilities, right, to our community, to who we interact, to our family. And so, yeah, you have behaviors, but how do you portion them out in a design? Well, you think about characteristic responsibility profiles and how they interact. So, for example, if I want to design an application, one of the stereotypes that we have is a controller, right? So it directs the actions of others. Well, if I want to delegate responsibility, then I might have objects that are designed, or functions, doesn't matter, that are service providers that do things on demand and hold on to things. And yeah, we have information holders and providers that maybe collect information. And we have objects that more coordinate rather than control. So I don't have to just understand the minute details if I can just coordinate without really knowing any of the details. And you can see a lot of patterns like that in the way modern frameworks for like reacting programming. Here's the event, go ahead, you handle it, whatever function or whatever. So these kind of behaviors that you have to partition are based on what kind of responsibilities you should have. And just profiling those has been very helpful. And it was just observing programs to come up with this. I guess it's learning how to see, nice structures of interactions.
So how does this relate, or does it relate in any way with the single responsibility principle, or was this kind of a separate idea?
Well, so single responsibility principle, of course, is something that the solid design principles, that's the very first one. Actually, the name solid was coined by Michael Feathers, but anyway, Bob Martin and the people he worked with at the time came up with that. There wasn't any really new innovation there, but they just packaged it into a nice set of names for things. And the single responsibility principle is described, though, as in a strange way, in my opinion. It came after, of course, responsibility-driven design. But it basically said, if there's a reason for something to change, you might want to split it into two. That's because they didn't want to use the word cohesion. Michael has told me, and I haven't talked to Bob Martin about this, we wanted to use different terminology for things. So if something isn't cohesive, it should have a singular responsibility, And one of the things that I find interesting about that principle is that single responsibility is not the same as single method. Everyone thinks, oh, so they want to have tiny, tiny little objects. And I'm going, well, that's just like a function. What's the value of that? But the idea was really for it to be cohesive, and if not, split. And that's, so, it may be, there is a connection. I'm sure they came up with that term because solid is a great acronym. If it was just ROLID wouldn't make any sense. So it had to be single responsibility.
Yeah, it's funny because I always look at terminology in software, and it's very confusing, particularly in
Really?
testing. So yeah, because for example, integration testing, I can give you at least 5 different interpretation of what an integration test is, and that is, to me, it's really weird that we kind of get into these semantics, different semantic differences, and uh, but anyway. So if you would compare the OOP, the object-oriented design as you see it, today there are a few things that I kind of hear often about objects. One is prefer composition to inheritance, and we kind of touch on that. Inheritance is not evil. Another one would be prefer interface inheritance over implementation inheritance. So instead of inheriting behavior, inherit just interface. And I guess the third, which is even more often, is the solid principles. These would be the 3 things that are very often mentioned about. And probably a fourth one is immutability, because immutable objects tend to be more interesting nowadays, apparently. So what do you think about these new interpretations, let's say, or is there anything new here?
So I'm gonna start rolling them back. Immutable objects are great, but controllers retain state. So it's not everything that's immutable. I tend to think that what I can do to not allow you to poke, setters and getters blindly is a good thing. But also, if I have people that are listening to this know about the value object, where I can have things that have behavior, and like I can do arithmetic with dates, or I could, create objects that instead of changing their state, if I combine one or do something to it, it creates a new one that's a small little thing that knows maybe its units of measure and its value, if you will. And there can be a lot of different kinds of value objects. Those are very powerful things. So it's not like everything has to be immutable. It's when I think about information providers, which was one of my role stereotypes, I tend to think about how it retains its information should be private. And so it isn't always just immutability. It's like the details of how it obtains information should be private, and it shouldn't be poked at. And then its behavior is predictable. So that's all I want to say about immutability. Now, solid principles in and of themselves, and I've taught object design to thousands of people, I find that they're pretty confusing. They're hard to explain. What is this substitution principle? What is dependency inversion? They're not exactly ways of telling you how to structure systems so much as checks against when something is violating a rule that allows you to change and make it a design be flexible. So while they may be something that is brought up, I tend to think that they're in and of themselves not that important. So now going back into, I'm going to go to implementation versus interface inheritance. Defining interfaces is really important, right? And the question I think that's really tough for people, we can talk about implementation inheritance, and I think we've already talked a bit about it. The thing about an interface is how big should it be? What's the scope of its API? Back in the early days of my very first designing object-oriented software book, we talked about the notion of contracts. Bertrand Meyer also talked about the notion of contracts in pre and post conditions. So he added the formalism to it. But our idea of contract was very simple. It's usage. What different potential users of this object or class would find this bundle of related responsibilities useful. And so from that perspective, I think that's very much in line with implementation, interface inheritance. Since we didn't have in Smalltalk the notion of even interfaces, right? You just had classes. We had to invent this thing called contracts in order to keep saying what the expected usage of various parts of it. And in fact, even in the early browsers, there were different categories that you would have for methods. And so I tend to really like implementation as being aligned with usage, right? So if I define an interface that can be reused regardless of class, and it's more than just, it has to be a cohesive set of things, then that's a good design practice. But is it a single method, or is it a single, what's the scope of it, an interface that I'm defining? And it really depends upon usage. So you have to understand if I want something to be storable or hashable or whatever, all kinds of things, then I have to really careful. It could be fairly small grained, or it could be large if it's in an application space. But yeah, I like interface definitions a lot. I tend to think that's the only way I could make sense of, classes, like, for example, Python. Everything's open and whatever. Well, so how am I really supposed to use this? I'd have to pick out the interface that was expected. It wasn't documented there. So that's, now implementation inheritance is something that I tend to think, again, if you're designing a framework or something that is constrained, that's not a bad thing. But it's probably not my primary concern. And if I'm doing it, again, I like designing configurable algorithms so I can plug in things. So like little strategies or things like that where behavior is predominant, not just inheriting masses of data. So.
So if you don't use solid principles to kind of look at the design, what would be a good set of constructive rather, or decomposition principles that people could use?
Well, so again, I was, and this is stuff I wrote about in the book that came out in the early 2000s, talking about understanding the control style of a part of your design, understanding whether how various roles, stereotypes interact, understanding behaviors, understanding boundaries of trust and exception handling. All these sorts of things help you, understand and structure stuff. Now, I do think that understanding how I can break something apart and practice practical techniques for managing dependencies, and not just a dependency injection, well, that will solve everything, but is another kind of dimension of that too. And so I have to think about cohesive, related interactions, and how do I want to structure them. The other thing to think about is in a lot of applications, there's a lot of information moving around. So I tend to think a lot of patterns around that, or knowing those sorts of patterns and practices. So if I have to shove data from one place to another, let's treat it like a DTO. They're not evil, data transfer object, but that's not the same as a value object that could have behaviors. So knowing these extra patterns, I think, is helpful to be more object-oriented. And so
it sounds almost like you have a larger vocabulary than
than just 5 principles. Yes.
Yeah.
Yeah.
Do you have any preference on the size of objects? Like, should they be very small, or can they be large, or can the methods be large, or things like that?
Well, so what's large? I tend to think that factoring, well, the largest method I've ever seen in Java, you want to guess what it is? And I didn't write it.
1,000 lines of code?
No, it's 2,000 lines of code.
2,000.
And that was way too many. Now, the largest stored procedure interface I've ever seen. Here's another test for you.
Oh, that's
how
harder.
many parameters?
Parameters. I think there was a limit, so I would guess to 100, but.
Oh yeah. So I've seen stored procedures that have 100. Okay, so those are like ridiculously incomprehensible, right? Now I tend to see, so those are like, no, wrong, too much. No one understands them, right? No one understands them. But I've also seen algorithmic calculations, and this is again for doing tax, but it's tax calculations across countries and different regions and municipalities that are horrifically long, right? That there may be a couple hundred lines long. And you're following the indentation to try to understand what's going on. And you feel like, wow, I've really accomplished something when I really understood that algorithm. And then I'm going, immediately, I can chunk up each little related, if then else, and turn it into an intentionally named function call or method. And then I would have the structure of this complex calculation with all of the exceptions and rules, which actually it's very hard to simplify that much more easily. So I tend to believe that that factoring things out into helper methods that are intentionally named is just like a golden thing to do. I naturally will do that. But I work with clients that like to see it all in one place, and I'm sure you do too. In fact, last week I was looking at a green screen because my client likes Vim. A client likes Vim, and we're looking at stuff that's a couple hundred lines long. Now that person feels very comfortable because it's all in one place. Doesn't have to go and see the calls, whatever, it's just all there. If I came there, I would do the refactoring. But I tend to think that there's this belief that everything should be 5 lines long or 10 lines long or less. And there's this personal mastery of doing that factoring and seeing the benefit out of it. And it's really hard once people just keep slugging away the code to get them to change. So either you start out that way and keep that at the intentional same name thing as you go. Very hard to introduce that discipline in when people are just writing big stuff. And they become so invested in that big, long method that they like to. So I guess I'm talking about big methods rather than big classes. That was just compounding it with classes with lots of those big methods. So anyway, my preference is for smaller is better, but sometimes algorithmic complexity leads it is not regular, and we can't all factor everything nicely, and I accept that. So it's a balance between that.
Mm-hmm. How about static? Is static evil or
static? Yeah. Well, what about well, I'm gonna say, isn't that sort of like immutable things? I mean, static means I'm not changing it. It's defined. So
well,
there are times when I need to do that. Okay, it's not necessarily always evil. If I can avoid having lots of it thrown all over the place, that's much easier to understand what's going on or not. And I'm thinking about some of the horrors I've had in programming in Java. Static final things there too. Not just static declarations of things. So another kind of thing to think about is if I'm writing in highly multi-threaded applications, how do I really reason about that kind of programming? And we haven't really talked about that kind of aspect, but I tend to think that it gets very hard to reason about. And so I understand why we want to have immutable, small little things, small little functions, small little classes, because we can't understand it.
Yeah.
Right? Until we need something to do big stuff. And then we need to guard it so that it can run in a single execution. And anyway, life gets hard when you do that kind of programming. So there is a reason to go towards small and well-defined things for that kind of programming.
All right.
It's still hard.
Yeah. I mean, yes, it is. To go back a bit to UML, I understand that when it first started, it was just a combination of different. Basically, people wanted some way to design, to draw the diagrams for the system, and perhaps to even link those with the classes and objects from the system. But so it seems that this is at stake with another statement which says that the design is actually the code, because when you build something, you build the code as the build process, and the blueprint used for building is the code that you write. And if you think like this, then the diagramming part is just one step remote from actually doing the design. And so what do you think about this tension?
Well, so that's an interesting point. I think that the design is realized in the code, but the design is not the code. So I'm probably, that's why I need to write index cards to really extract the design from the code. So in some sense, if the design is realized in code and the devil is in the details, that's another phrase we have, right? So even any sort of representation of the design is an abstraction. The details obscure the design too. If you think about programming and, oh, why is this little exception coming and why am I handling all this extra stuff? So in some sense, the design is probably realized in the code, obscured by all the extra little programming whistles and bells that we have to do. And it's also represented in some kind of abstraction that we might create, right? Like a diagram or a CRC card. So there's no way that we're really understanding the design. We're just trying to feel around and find it. One might say that tests are one way of getting at what the design is, because we're seeing what behaviors happen during execution, which we don't just see by looking at the code. So I think ways of understanding the design, there's quite a few of them, and we need to be open to that. And not everything one of the things that people worried about in the days was like, I specify something and then it doesn't match what the code's doing. Well, just the same thing happens with my tests. They're capturing only the essence, as you were saying, right, in your Ruby tests, but there's so much more detail in the code. So, I think understanding what the design is, we need to have different windows into it. And from my point of view, whenever I'm doing that, it's always an interpretation of some aspect of the design that I'm looking at. Right? So it's not the design. So this like, oh, it's all there in the code. Well, yeah, maybe. And then there's some stuff that's just there for the implementation, right? If I want to, like in Java, you have to implement hash and equals, right? You have to implement things if you want things to serialize, right? Correctly sometimes. Is that part of the design, or that's just implementing to make it fit into this stuff? And then all these exceptions that you have to declare that you don't ever throw, or whatever. There's extra stuff that's just part of the implementation that kind of obscures the design, in my opinion. Anyway.
So for programmers that are kind of at the beginning of their careers, is it worth learning UML today?
Well, so UML is still, it is a book written long ago by Martin Fowler, and I don't know how many millions of copies he probably sold. But in some sense, understanding how to represent classes and relationships between them in a simple way, and simple sequence diagramming, what happens next, is useful to kind of know. I tend to think that beginning programmers should use a free tool and not pay for anything, but that it's not bad to learn how to express design ideas by drawing on whiteboards too. It's not always just hands down in the code. So when I work with clients, sometimes remotely, these days we're using things like, online drawing tools, Miro, whatever, various tools to draw. And we do that. It's okay. We write responsibilities on stickies and put them up on a wall, virtual wall. So it's useful to represent ideas about design at different levels, not just always at the program level. But don't get hung up on, every last, what's the shape of my arrow? If you're trying to create something that you aren't having a conversation over, that's a different matter. But if I'm trying to converse about design, learning a little bit is not difficult. Now, one thing that UML didn't do is it didn't get updated for, it's the unified modeling language for objects and classes, not for functional design.
Yes. Okay, so before we close, because we've been at it for quite some time, I still have a lot of questions, but I guess they will probably have to wait for another conversation.
Sure.
But what would be really interesting is, I know that you are currently working on with the domain-driven design communities on design heuristics. Could you explain a bit about them and why they are interesting to you?
Well, so it's interesting that I started thinking about heuristics because a colleague that I used to go out to breakfast when we could meet together challenged me. He says, "Oh, you need to read this book by Billy Von Cohn on the discipline, talking about how do I do engineering." And Eric Simmons is the name of this fellow. He's a really good friend. He says, "I want to see what you think about this and how this will change your idea about patterns everything that you do in design. So I read Billy Von Kohn's book, which is kind of hard to get because it's out of print, and it totally flipped me into an interesting perspective in that, and to boil it down into a nutshell, it's a heuristic is anything I try that's not guaranteed to work, is potentially fallible, it's maybe useful, it's moving me in a forward direction towards my ultimate goal as a design, where I could be engineering climate, response to climate change, or I could be writing an application. There's no guarantees, and I thought about it. Certainly that's true for patterns, right? We know that just blindly applying design patterns leads to pattern soup. I mean, you've seen overuse of design patterns. And then there are so many different ways that I approach a design problem. And if I am a student of patterns, or let's say solid principles, there's so many details I have to fill in. Like just even implementing the observer pattern, you have to realize that you have to understand what's meaningful updates, how do I respond so that I don't, there's just, so patterns don't tell you how to really design. You have a lot of wisdom in your head. And so there are heuristics also, besides all these little techniques I might use, with no guarantees that they're going to work, by the way. And I'm not to make it bleak or unhappy here, but there's also heuristics that guide my attitude and behavior as I approach design. So if you believe in consistency, or if you believe in expressing how something works, not just by executing it, by executing tests, that's going to drive your behaviors and the way you choose to do things. So anyway, so heuristics changed my life. I started writing some essays about it that are available online, and were in the, revealed to the patterns community, because I was getting a little depressed. It's not just patterns is enough. We have all these heuristics. Can we share them? What can we learn from learning our go-to or favorite heuristics? And quite frankly, the community that I found interesting and interested in design was the domain-driven design community. So I took these ideas there, and we've been, I've been working with people, and they've been taking off and writing about heuristics and trying to fill in the gaps and share about these sorts of things. Now, the thing that's interesting, have you ever had a design disagreement with someone, Alex? Like maybe your brother?
Never, no, never, of course.
Well, so one of the things that's probably to be aware of is when I have a design difference. It could be that my values at the moment, and values are context sensitive, right? So my perception of, well, we need to do this thing or this in the design might be because I perceive the risk of not doing something higher than someone else. So we have a difference of opinion. So just sharing what my driving heuristics and the current values that are at play, so I can have a more intelligent conversation rather than, no, your design's wrong, no, mine's wrong, no, I'm better, worse. Let's just have a discussion about it. There's always more than one way to solve a problem. And the heuristics we apply as we make decisions and move forward in our design are, it's fascinating. So even just having differences of opinion is because probably certain heuristics are like firing in our brain that like they're really important, but we need to step back and realize that there are always alternatives and try to have more intelligent experiments about things. So I've been working with the domain-driven design community because they like to talk about design. They like to talk about, well, how do I create good structures? How do I talk about design of event stores and event architectures? How do I talk about doing event storming? How do I talk about the right boundary for a bounded context? So there's many here. How do I get people to talk about the model? Or what's the language we use? And so it's a very ripe community for having these kind of discussions. So that's kind of what's been going on there. If any other community wants to talk about heuristics, people in the testing community, I've been having conversations with folks there, but usually those are one-on-one kind of like, I spent some time with the Cucumber people who implemented Cucumber and distilled and shared with them some of their heuristics as we spent time programming together. So it's just a thing that I find very rich and very satisfying. Kind of, there are so many gaps, and we have a lot of knowledge, and we gain it through experience, but we need to be sharing it. So that's kind of what I'm doing with heuristics.
So where can people see what's getting out of this idea of heuristics in design? Are there articles or?
Yeah, well, so I have a few blog posts about it. There are some talks that were given at DDD Europe that are online. I think we had a talk. I had a talk with you. I think that there is the website for the DDD heuristics, and I can send that link where people are putting their heuristics down.
Sure, I will add those in the description of the video.
Yeah.
So it's interesting to me because I've been looking at how other designers learn design. And part of it is if you go to a design school, for example, industrial design and so on, you get a project, design a chair. And it turns out the chair is fairly difficult to design. And actually, whenever a new design current starts in these types of design disciplines, the first thing they do to show off their design style is to design a chair, because that's very distinctive from a different style. But in order to do that, they never accept one solution. You have to come with 3-4 different prototypes, different solutions to the same thing. And this is something that at least I have missed in software, because the university I went through, it was more like, so you have this algorithmic problem, find the solution, or this is the solution. Not so much about, find 10 different solutions and let's discuss advantages and disadvantages and trade-offs.
Well, so I think that actually when we were in the Smalltalk programming environment, not only were we trying to write applications, but we were experimenting all the time. So we were what we call noodling around, just even as we were building things. That environment sort of encouraged that sort of alternate thinking. What if we did it this way? And we did that. Now that kind of experimentation didn't really get into the XP practices. The only experimentation was, the design spike, right? Oh, if there's something I don't know how to do, I don't have to tell anybody. I can just go off and play around for a couple of hours, right? As long as it doesn't affect my schedule, I can do a design spike. Now, one of the interesting things about design spikes in the original writing about XP was you could throw it away, right? As long as you learned something. But these days, people think about, well, I have a spike solution, right? They're exactly what you're saying. I'm going towards the one solution. It's not that I get to experiment around the edges. On the other hand, I've seen Woody Zuhl and mob programming. They come back and do experimentation as well. Okay. As part of their daily work.
All right. So before we close, is there anything else that you'd like to tell our audience?
So keep learning and experimenting. And I actually think that thinking about design options, even if you're in an environment where you're driven to deliver story points faster and faster, is worth the time. As I was saying before, we kind of got muddied here, like the mob programming groups that I know from Woody Zoll, they devoted an hour a day to learning. And, before we get into solving today's tasks, if we could just spend some more time learning and understanding more about design or our tools and technologies, learning is so important to being productive. So try to fit that in.
Okay. Thank you, Rebecca. This has been an absolute pleasure.
Likewise.
And it's always a pleasure to discuss with you. And going back to the audience, as you can see, Rebecca has a lot of deep insights into objects and design and architecture. So I really encourage you to follow what she's writing and to perhaps also find some of her books, because you may find interesting things there about how to design your code better. And so it's been really great to have this conversation. We'll come back with new conversations. Until next time, remember to think design and work smart.